Today we're going over chapter 3, section 1, which is identifying pairs of lines and angles. So parallel lines are coplanar lines that do not intersect. Skew lines are non-coplanar lines that are neither parallel nor intersecting. If you guys raise your hand, I can pause the video.
Oh.
Yeah.
She didn't do it.
No, I turned around.
She turned around and waited for me to say something. Okay. No, I was just going to keep talking. A good example of parallel lines, you guys can look at the board. You see how the top and the bottom lines of the board never touch? That is a great example of parallel lines. You see it in a classroom, you see it, the walls don't touch the corners, each side, that those lines are parallel lines all the time because they will never, ever, ever touch. Now, skew lines, they're on different planes or in different directions, so they won't touch either. You can think of it as, let's say, the top of the board and then the floor. There are different angles, but they're still not going to touch. So, parallel planes are planes that do not intersect. Guys, I want to remind you that the way you name planes is you have to use 3 or more letters. So, please remember that. Now we're talking about parallel planes. Parallel plane, for example, could be the plane up here and the plane down here. So let's write the example. So plane, let's call it ABH. We can also call it, just as an example, ABG. And plane EFD. Again, as an example, I'm just going to rearrange the letters. DFE, that's also allowed, different orders. Those are 2 planes, the top and the bottom, that are parallel. If I change the color, these 2 are also parallel. Plane AGF and BCE are parallel. Same with the front and the back of the rectangular prism. Those are also parallel. Again, they just don't touch. They're forever going in the same direction, so they're never going to actually touch. These are postulates. So parallel postulates, if there is a line and a point not on a line, then there is exactly one line through the point parallel to the given line. And then the perpendicular postulate is if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So what the parallel postulate is saying is if there's a line, let's say right here, we have a line right here, and we have a point not on the line right there. That means that there will be a line going through that point in a parallel motion. And then for the second one, is telling us if we have a line, and there's a point not, sorry guys, hold on, I flipped them. No, so the first one I did was correct, guys, sorry. The second one, again, is still a line and a point not on the line, but the line is going into this direction. It gives us a perpendicular line. It just depends on how the line is drawn. It'll give us a perpendicular or a parallel. Transversals. So a transversal is a line that intersects 2 or more coplanar lines. So transversal is, it's a line, right? 2 or more coplanar lines is just, honestly, just 2 other lines that are, let's say, parallel or not parallel. It's just a line that intersects 2 other lines. So I'm just going to highlight intersects 2 or more coplanar lines as parentheses. Just let's name it line M. Just to name it something, because in the example that we're going to go over in a second, the transversal is line M right here. So they want us to do interior angles and exterior angles. So I'm going to do it in red. The interior angles are all here. the reason those are interior angles is because they're the ones being cut by the transversal line M. And they are in between the two lines that transversal is intersecting. So I'm going to write the interior angles are angle 3, angle 4, angle 5, and angle 6. So the ones in the red box. So the exterior angles are the opposite angles, the ones outside of the red box. So they're going to be angle 1, angle 2, angle 7, and angle 8. So I'm going to write here outside of red box. Now, keep in mind you can draw this thing in infinitely many directions. Another example could be this same shape. I can draw it like this. So this is line J, this is line K, and this is line M. And still, the angles in this case would be 1, 2, 3, 4, 5, 6, 7, and 8. So I'm going to highlight it in green. Again, the interior angles are this ones. Doesn't change anything which interior angles are what. They just, honestly, you can draw it in many different shapes, many different ways, and it would still be correct as long as you follow the instructions on how to get the interior and exterior angles. Now we're with the alternate interior angles, are two non-adjacent interior angles on opposite sides of the transversal. So I'll give you guys the explanation in a second based on the example. I'm going to read alternate exterior angles are two exterior angles on opposite sides of the transversal. So let's identify the transversal. The transversal again is line M right here. So if I put inside the box or inside the red the interior angles, great, we have 3, 4, 5, and 6. Now the key word right here is the word alternate, because the alternate interior angles are going to be opposites of each other. So if we write it down, it's going to be angle 3 and angle 6, and also angle 4 and angle 5. Now for the exterior, we have the same thing happen. The exterior angles are 1, 2, 7, and 8, again outside of the red circle, and again they're going to be the opposites. So 1 alternated is 8, and 2 alternating is 7. So the alternate exterior angles are going to be angles 1 and 8 and angles 2 and 7. So these are the special angles continuation. So same side interior or consecutive interior. Those are the two interior angles on the same side of the transversal. So let's look at the keywords in the example. Same side of the transversal and interior angle. So those are the angles you want to look at when doing this. So same side interior are going to be these two. Again, the interior angles are the ones that are in between the two lines and cut off in the middle by the transversal. So are going to be angle 3 and 5 and angle 4 and 6. Now for the corresponding angles is two angles in corresponding positions relative to the two lines. What does that mean? So if we were to box in these 4 angles, you guys see how it's cut off in like 4 quadrants? We can say that angle 1 and 5 are in, let's call that quadrant 1, 2 and 6 is 2, 8 and 4 is 3, and 7 and 3 and 4. So what you're honestly saying there is they're in the same position based on the line. So right now, not necessarily equal or congruent. It's more of they're on the same area. So the same side, the top corner, the left corner, top or down, depending on which one. So I'm going to write angle 1 and angle 5. Then I'm going to write in blue the following, which is angle 2 and angle 6. Then I'm going to keep going in red for angle 4 and angle 8. And lastly, in yellow, for angle 3 and angle 7. So let's do this first example together, just to go over if it's something true or false. So a transversal intersects only in parallel lines. That is false, guys. Let me change a different color. That is false. We saw just now that it didn't intersect the parallel line. It intersected something that looked like an A, like that. So it's false. It can intersect more than just parallel lines. For B, skew lines are not coplanar. True. So there's skew means not intersecting. Now the reason they're not coplanar is because I'm going to try to draw here. We have two planes. We can have a line going on this plane like this and another one like this. Since they're on different planes, they will never touch, but they're skewed lines. So they're not intersecting. For the third one, if two lines are coplanar, then they are parallel. Again, that is false. We can have a plane. We can have a line going like this and a line going like this. So those will intersect at some point, but in general, they're saying that two lines must be parallel if they are in the same plane, which is false. Now lastly, if two lines are parallel, then exactly one plane contains them. In this case, we can say it's true. We have one plane, and we have two parallel lines, let's say right here. So for lines to be parallel, they have to be on the same plane in order for them to be parallel. If not, they would be considered skewed. Or they can be in a different plane parallel to each other. But yes, if two lines are parallel, then exactly one plane contains them because they share the plane. Remember, a plane can be in any direction. So even if you have a cube, they can be parallel. It's just it would be at a different angle, the plane, but it's still containing the two lines. For question A, they're telling us line S, or lines parallels to the line CD, are containing point A. Now, these are the lines parallel to line CD. We have line AB. Let me choose a different color. We have line AB, line HG, and line EF. Now, they're telling us it contains point A, so the only line that contains point A is actually line AB. I'm going to erase the highlighters to work on the next one. So, the second one, it's telling us that there's a line skewed to line CD and containing point A. Now, both line AG right here and line AH right here appear skewed to CD and contain point A. So actually both of these are valid answers, HG and HG. Then let's work on C. Lines perpendicular to line CD and containing point A. Now, the perpendiculars are BC, that one, AD, this one, DE, which is this one, and FC, which is the one in the corner right there, all appear to be perpendicular to CD. But the only one that contains point A is AD, line AD. Lastly, we have point D, which is telling us that plane or planes parallel to plane EFG. Let's find EFG is this plane down here. Are containing point 8. So plane, I'm going to call it ABC, which is the top one right here, appears parallel to plane EFG and contains point A. So that will be your answer, plane EFG. Yes, you just brought up a good thing. I honestly I just renamed the same plane, so this one. I meant to say plane ABC. Thank you for pointing that out. I just renamed the question. So we have alternate interior angles. Again, the interior angles are these. The alternating are the opposites of each other. So we have angle 2 and 7 and angle 3 and 6. Now we have consecutive interior angles. Again, the interior angles are still the same, but consecutive is they're on the same side. So it would be angle 2 and 3 and angle 6 and 7. Now for the corresponding angles, remember guys, if I were to put them in both of these in like a box, they will go in the same area. So the top left corner with the top left corner, so that would be angle 1 and 3. We also have angle 2 and 4. We also have angle 5 and 7. And lastly, we also have angle 6 and 8. Now I'm going to erase these boxes. Lastly, we have alternate exterior angles. Now the exterior angles, I haven't marked it. I usually just mark the interior, but let's mark them with blues. So those are the exterior. And again, they're the opposite of each other. So it's going to be angle 1 and angle 8. And lastly, angle 5 and angle 4. Okay guys, so your homework is some big ideas. It's due tomorrow